We're doing a system design case. So I'm interviewing Alexander Barmin, senior software engineer at Wise.
Yeah, hello,
Let's go.
Vladimir. Thank you very much for having me today. Designing the collaborative text editor like Google Docs is not an easy peasy task. I will do my best to present the solution I have in mind and hope together we will make it even better.
Yeah,
Let's do it. I will share Draw.io.
Sure.
Let me try to refine some basic requirements because Google Docs is a well-known, allows us to do something like a collaborative text editing. I will write it down. Collaborative edit of text, right? This is the main thing why we use Doc, don't we? Next, we also have some basic styling, right? Basic styling, like it allows us to insert images, it allows us to insert links between documents, do comments. Obviously, there should be some way to authenticate users, right? Because some documents have restricted access and should not be publicly available. And other than that, we have different user types, right? Yeah.
Yeah. So we should be having
Yeah.
readers, commenters, editors, and owners.
Readers, commenters.
So the letter can do everything.
And owners, and people who should see everything. Okay, so if I remember correctly, it's a quite comprehensive application. It works on major platforms, like it works from the web browser, it works on mobile, on tablets, and so in a nutshell, there are different kind of clients, right? True. Okay.
Yeah, true.
Sounds not bad. Let's do some capacity estimates. But before doing that, let's think a little about these four major requirements. Apart from these functional requirements, we should definitely have some non-functional requirements, like we already introduced some, like user should be authenticated. I think another should be that system should provide some kind of availability.
Yeah. Let's assume 4 nines of availability.
99.9. That's a lot, by the way. It's quite high. Quite.
No, what you
Yes.
wrote is 6 nines. But I meant
Yes,
4,
indeed, indeed. But I still believe that Google works at quite high reliability and availability. So, apart from that, what else do you think we should consider as non-functional requirements? Because
Need the number of users, and if we're doing capacity
Yes.
planning, we need to have some assumptions on the average document size and the number of documents that we're
Yes,
gonna store,
indeed.
right?
So let's assume we have, let's say, 1 billion users daily, which I think is
That's quite a lot. That's basically all the half of the internet users on
Yes,
the planet
indeed.
Earth.
But we also should consider the average size of the document. If we remember that we have web major text editors like, for example, Microsoft Word, the file size of the Microsoft Word document is quite big. And it is big because it has a lot of things inside, because the document should be self-contained. Speaking about the new solution which we're building from scratch, what we could do, we could, let's say, assume the document size is kilobytes or even very few number of megabytes.
Let's go with 1 megabyte.
megabyte. Yes, for simplicity.
But we also need the average number of documents per user. And also the question is, do we want to store the versions of the document, or it's
Indeed
just
we will.
like
Indeed we will. Indeed we will, but we will do it in a slightly different manner. Okay, so let's assume every user create at least one document daily. One doc. Yeah, why not? Why not?
Okay.
Because
That's
yes,
gonna
that's
be
gonna be challenging because we already have around 1 terabytes of data daily, don't we? Yeah, so it's average 1 terabytes of data daily.
How you came up with this number?
So maybe it's not 1 but 10, but still, let's try. So 10 billions, it is, how much is it?
1 billion, like the useful practice is not to use the numbers, but use powers. So it's 1 billion is 10 to the power of
9.
Oh. 9? Mm-hmm. No, 9. Mm-hmm. 6 is a million. 1 megabyte is 10 to the power of 6. So
and
that's megabytes.
multiply.
And doc daily, that's 30 documents
Sure.
monthly or 365 documents
Let's start with
annually.
daily. Let's start with daily, and next we will multiply it. So what's it
Okay.
about to be 15, isn't it? Not really good at math at my age. 10
Yeah.
at 15th.
Never do math in the YouTube
Yes,
video.
indeed. 10 at 15th. How much is it, by the way? Billions?
It's 1 petabyte.
Hell. That's a lot. Okay.
Yeah,
Yeah, so
true.
yeah,
And that's
that's daily.
daily.
Maybe we should consider something which is not so big. For example, not a billion documents daily, but at least million.
Yeah, I think what should be a more realistic estimation is probably 1 billion users
Okay.
total, but million, yeah, so I don't know, probably 10 million active users
Mm-hmm.
daily makes more sense. So how it changes the calculation then?
So if we have this in total, so let's do some 10 millions total, and one dog daily, and we need to multiply it to, come on, 10 15s multiply to 365, don't we?
You need to change the numbers. So it's 10
Mm-hmm.
million daily, then you don't have 9, it's
10
7.
million daily. Why 7? Because it's 7.
7, so yeah, so then it's 13, so it's how much? It's 10 terabytes. That's more
Yes,
feasible.
that's more feasible. Yeah, you're right. Never do math during YouTube, during on YouTube. You will be definitely shamed.
Yeah, that's one of the challenges of the system design task. So you should be really good at
Mm-hmm.
multiplying those numbers and knowing the names for the numbers. Okay.
Okay, so let's do the most interesting part of the system design. I think let's try to identify architecture significant requirements which affect our design the most, right? Yeah, well,
Okay.
so apart from capacity estimations, what else do we need? What else do we have? I think that's it, at least on a superficial level.
That's the performance requirements, and we partially gathered the security requirements. However, we can finish those because that's not enough. Like authentication authorization is good, but is it enough from the security standpoint?
Security standpoint, I think, yeah, from security standpoint, obviously we should apply some encryption on the backend so documents are not available. Okay, let's talk about security in details. First of all, we in almost every region we have some GDPR-like requirements. So data.
Oh, wait a second. That's more regulation.
Nevertheless, it's a regulation, right? But still, it affects the design of the system because it affects the data locality. Nevertheless,
Ah, okay,
yeah,
okay.
data should be stored in the region of origination. It's important. Obviously, there should be some encryption, so no public access to the data. Even if it is stolen, it should not be possible to decrypt it, at least easily. What else comes to my mind is.
When you say
Mhm.
encryption, so can you elaborate where you're gonna use the encryption? So is it data in transit, data in rest? Like what tactics you're gonna
Yeah.
use?
So indeed, the data at rest should be encrypted, but it's easy. We will apply something like SSL TLS. It's good. Date stored data, I think, also should be encrypted. Stored data.
No, when you say data at rest, that's stored
And
data.
then
So
transit.
it's not TLS. Yeah.
At rest and then transit too.
Okay. So we need to secure the communication between the web and the mobile and the backend,
Mm-hmm.
first of all. And second, we need to protect the data stored like in the database in the
Mm-hmm.
long-term storage, right?
Okay. So what else regarding the security? I think it's mainly it. As you mentioned,
Okay. Yeah, any other non-functional requirements that you
yes,
want
I
to
think I
cover?
want to slightly talk about performance because
Hmm.
this is a significant requirement for this solution because it's not going to be easy to achieve it. And even hard to, I think, to come up with proper wording for that. Because what I have in mind is all users eventually should see the document, the same document. Yes.
Okay.
Hmm?
Good idea. This eventually, let's have some
Yes,
time
indeed.
bounds. Is it like 1 second, 5 seconds, an hour?
So let's say that it is 1 second when connection is available. Yeah, because one
Okay.
second when connection is available, I think it is achievable.
Yeah. When we're talking the performance requirements, it's insufficient just state a number. We need to know the probability or like the percentile when where we want to achieve this. Is it like 19th percentile, 99th percentile?
Let me think. 19 percentile, 99 percentile. Uh, let's start with easy percentiles. 90 percentile. That in 1 second,
Okay.
documents should in sync when connection is available. Let's say it this way.
Okay. Okay. Sounds good. All right. Let's start designing because we spent already like 15 minutes gathering the requirements. I think
Mhm.
that's enough. And then we can elaborate on interesting parts. So let's start drawing the
Uh,
rectangles and arrows.
okay. So I think the most interesting part of this design is of this solution is that actually it's a collaborative text editor because it's not so hard to achieve the security with encryption and data locality. We have a lot of tools and services which allow us to store 10 terabytes of data somewhere. Authentication again is not a big deal, but collaborative text editing is something which is quite challenging. So
Do you want to know how to design proper software systems? Do you want to grow to a senior or staff engineer positions? I developed a business oriented system design course specifically to achieve those goals. We're gonna learn how to identify and gather the requirements and also prioritize them, how to address performance, security, reliability requirements, how to document software architectures, and how to make architecture decisions. The course consists of 10 lectures, 10 home tasks, and the final work. You're gonna receive the graduation certificates by the end of the course. All the details by the links below the video.
in a nutshell, if we start thinking about the design, what we should have, I think it's better to start with some simplistic solution, right? We have our user or many users, and every user should be able to access the system in its own region. If we need to do, we should definitely have something like an API. Something first of all, the system assumes synchronous communication, and it also assumes almost real-time communication between the application and the service itself, right? So there should be something which is on the user side, like a mobile application or web application or something.
Okay.
So
Yeah, Google Docs
yes,
indeed have
indeed.
both.
So for simplicity, it might be something like a progressive web application because we're designing from scratch. It can be anything. Secondly, as it assumes synchronous communication, we should have some kind of a synchronous protocol between our application and some backend. Again, it could be anything, but let's start with something which is well known. For example, WebSockets. Just because nothing stops us.
Why do you want to use WebSockets instead of REST API here?
Because we have requirements of if we have an interest in requirements. So REST API will not allow us to push the changes. I would rather say if our application actually has more than one part. So obviously there are some things which allow us to list the documents, to create a new document, to read the document once and next update it. And when we need to do this collaboration, we need the changes to be propagated to all the participants almost instantly. And in this case, REST API might not be the case because it doesn't allow to push the changes, it allows to pull the changes. So this is why I suggest.
Okay. Do we have any alternatives
Obviously,
for
we do.
WebSockets?
For example, we could use WebRTC because it also.
Okay,
Yes, why
interesting
not?
choice.
Because there are some solutions which are document editing solution or collaborative solutions which are built on top of WebRTC. So if you have
Okay, what about server sent
server
events?
sent event, also we could use it. Why not?
Okay, okay, but let's go with WebSockets. Okay,
Yes,
let's
indeed.
proceed.
So next we should have kind of an API gateway because ideally there should be some entry point to our application, right?
What purpose does API
Okay,
gateway
it has
serve?
many purposes indeed. So first of all, we have requirements for authentication of users. Other than that, we have some requirements for availability, and we have requirements for data locality. So API gateway and global DNS routing could help us routing users to the proper location. So user from the United States could connect. Uh, well, okay. DNS. Obviously, we couldn't avoid having DNS, which will route users to the servers in their region. Apart from that, we should definitely have API
Okay,
gateway, which will serve as an entry point to the application, because we should definitely scale
okay.
our solution.
We start with the DNS-based
Mhm.
load balancer, which will, yeah, which will settle the request on the API gateway in the
Yes.
appropriate region. Okay,
Yeah, so
sounds
Route
good.
53, this is something which I have in mind, but obviously, if we build in Google Docs, there should be something from the Google ecosystem. Okay, API gateway. Oh, that's interesting a bit because we have two streams of traffic. We have pull traffic and we have push traffic, don't we?
Okay, what
Let's
do you
start
mean
with
by
the
this?
simple one. So when you open the Google document, the document is loaded directly to your browser, right? So it means that true.
True.
So it means that there is a farm of servers. And I would definitely keep in mind that we have a super huge amount of users and we have online collaboration. I would definitely split the traffic between pull and push routes. So pull or
Okay,
read traffic. Obviously, we could split it by different methods in our API. So in this case, we would send traffic to some read servers, which allow the data to be read from some storage. And what we're going to store? We're going to store document snapshots. And
okay. What are the
okay.
document
And
snapshots?
in order to explain why do we need to have document snapshots, I need to tell you a little about write path. Yes,
All
because
right.
read path is quite easy, but write part is a bit more complicated. So let's take a step back a little. So even if we have user A and we have a user B, they should somehow, let's say the main challenge of this design task is to establish the collaboration. These people may have multiple things. So in order to establish the collaboration, what we had before Google Docs, we had an email, right? Where you create a version of document, send it somewhere, next the second user receives this version of document and sends it back. It worked, it worked. There are obvious downsides of that. Apart from that, what else we could do? We could use a Git-like system when we have a storage and we have some tooling which allow us to, let's say, to distribute documents from person A to some central
Hmm.
server and next store the version of the document. And next, this document is pulled by user B and all the necessary conflicts are resolved. So you never seen conflicts on Google Documents, right? Don't you?
No, I
Okay,
didn't.
great. In this case, the better option, but in this case, when we send a document, we need to have a way. first of all, what we need to do, we need to avoid having conflicts. And obviously, there are some solutions which allows us to do that, and it is called operational transformation. So instead,
What's that?
so you can imagine the document as a collection of changes. So obviously, the document itself is not a big, let's say, it's not a big. In a nutshell, it's a big blob, but inside the big blob, you have parts of the document, right? For example, you have characters. And instead of saying that I want to sync the full document, I will represent a document as a collection of changes. So if I want to write, yes, if I
All
want to
right.
say I'm writing a hello world, user A creates a document which contains a hello world. What it needs to do, it needs to send a command like I'm inserting H at position 0, I'm inserting E at position 1, I'm inserting L, and so on. And when user B
Okay, so you're saying that the document is not just the text, it's actually a history of changes made by the
Exactly. This is
users.
the history of changes made by users. And next, user B should receive these changes and recreate the document on its own site. This is why I suggested splitting read and write pathways. Because when we have a write, every change should go via central server, ideally. And this central server will
Mm.
next change this change across other users. So we have user B, you have user C, or for example, you open the same document on the mobile.
Mhm.
This approach is called operational transformation, and the main downside of it that there should be a central server which accepts all the writes and next distributes these writes across other users. It
And that's why we need WebSockets to actually
Indeed,
distribute those
indeed. We
rights.
need to distribute that rights across others users because we have requirements. User should eventually see the same document. Because in ordinary Google
Okay.
Doc, you see the changes which are made by other users. But operational transformation has significant downside. Obviously, it should follow some rules. For example, well, under the hood, it uses some math which says that there should be function which allow to merge different version of documents. But the main downside of it is that it's all the writes should go via the central server, which next will distribute these writes across other users. Keeping in mind number of users we have, number of documents, and the fact that we have different requirements and different clients, it will not work for us. This is why people from math, people who has no life, come up with a different approach. They created CRDTs, conflict-free replicated data types. And the idea is that, yes, we distribute writes across nodes. And next, there are some algorithms which allow us to combine these writes to eventually together back. Okay, without talking about this math, what I suggest to do is to have write servers. And these write servers, what they will do, they will accept, obviously it's a farm, they will accept requests, write request or insert requests from our clients and save them into write storage. What it allows us to do, it will allow us to have multiple write servers and it will be horizontally scalable, and also it will allow us to have write storage. So as we reach in this 10 terabyte storage, we can introduce more write servers, so our solution is not limited. This is why we
Okay, so basically we need scaling because it's hard to store 10 terabytes or more in a single node. So we need
there are multiple
multiples.
reasons. So it's not a problem to store 10 terabytes. We also need to have our solution reliable because we have some reliable availability requirements. And secondly, when you write in the document, you do a lot of inserts. So it's gonna be quite huge amount of traffic to be served. Yeah,
Okay.
so horizontal scalability here not only allow us to handle more traffic or store more data, but also allow us to satisfy our availability requirements.
Okay, so it makes it more reliable
Mhm.
and available.
Availability, easy. Next, what's next? We still not connected read and write pathways. So ideally, when a new user joins, a very simple way what it should do, it should recreate the same document, right? And there are multiple ways of doing that. So first of all, it could read all the reads which were done by all the collaborators before, and all these changes are applied to the document. So user just read, insert H at position 0, E at position 1, L position, and so on. It's not good because there might be a lot of changes in the document, because literally we're reading the full history of document, history of changes. So instead of doing that, when you open the Google Doc, you immediately see all the changes. So we need to have a way to create a snapshot of the document, and by reading that snapshot, the newly joined user be able to start collaborating. So we need
Okay, so it's some kind of a Markov chain, right? So we don't care how we ended up in a particular situation. We can just create a snapshot and share it with the user and allow them to receive the flow of the
exactly,
updates.
yeah. So, and for doing that, I think CDC might be the good option.
Yeah, what
Change
is
data
CDC?
capture.
Okay,
It
what
allows
it
us
does.
to capture all the writes which we did to the write storage, as it literally every time the collaborator makes a write to the particular document, we receive an event saying that, okay, there is a change in that record and new character is added. When this change is received, we can actually act on it somehow. And in our case, we will store the
Okay,
changes in one, maybe not central location, but in the snapshot storage, which will next allow us to recreate a
okay.
document.
So do we update the same snapshot of the document or we create a new one?
Let's talk about snapshot. That's a good question. So let's talk a little about how data might be distributed across write servers. As many write servers might be involved, as many users from different regions might be involved, it doesn't stop us from having different inserts being originated and stored on different write servers. But the main idea of the document snapshot storage is that we have all the writes related to the same documents together. So we never update the snapshot, but instead we store all the changes related to the same documents, let's say in one table or in one partition, which allow to read them
Okay.
all together at once. So imagine this H and E are on one server, L and second L is on another server, but on the snapshot database or snapshot storage, all of them are together, stored together. And in this case, new collaborator can read all of
Okay.
them in one go.
Okay.
Okay, so I have just now realized that actually it's called CQRS.
Yeah. What's the
Command and
CQRS?
query request segregation, because this is what we've done. We segregated command requests and read requests. Okay, yeah,
All
CQRS.
right.
Okay, so without talking about underneath details of CRDT work, we also have some requirements to satisfy, don't we?
Yeah.
So what's left? Okay, let's go from top to the bottom and see what we didn't manage to satisfy. All users eventually see same documents, so they will, just because write servers will notify, because ideally write servers should notify other collaborators about the changes. Obviously, in the ideal world, the notification should be done immediately, but we understand that it's not always possible, so we should have a notification queue, which will next be sent by some notification sender. Yes, indeed. So
Okay.
the writer writes the data, it goes this path, written to the storage, and next write server somehow puts notification into the queue, and notification sender sends read messages from this queue and send WebSocket notification back to
Mhm.
other collaborators.
I suppose not only WebSocket notifications, because you can be offline, so you should be let know that there are changes in the document that you own, or
Well, you mean to say some email notifications on something like that?
yeah, emails, push
Yeah, okay.
notifications.
Let's separate them. Let's say we have a notification about write notifications, because this notification should be delivered almost immediately to justify this requirement that users should eventually see same documents within 1 second, and we see some application notifications. So document notification sender, and document level notifications like about comments and so on, because this is not a challenging thing to send notification by email. I think the most challenging part here is to satisfy requirements about eventual consistency on all devices. So what else we have in our requirements? Basic styling, it's provided.
Yeah, basically, how we I suppose the styling itself is
Mhm.
relatively easy given the solution that you provided. But the question is how we're going to support images.
How we gonna support images? Okay, so that's a good question. So first of all, because I'm saying that to have some time to think, let's assume that we don't store images here in the document directly. We don't store images in the document directly, so we should have a way to load images from to embed images and store blob files themselves somewhere else. So ideally, there should be something
Mm-hmm.
like a
Mm-hmm.
Google Drive like solution for blobs.
Yeah, so it's basically object
Yes,
storage.
solution for blobs or object storage. Yeah, let me call it object storage.
I think in GCP it's called Google Cloud Storage,
Yeah, or S3
right?
in AWS. Yeah,
S3,
so
yeah.
we have some kind of an object storage. But anyway, storing the file, it's storing a single file at scale is a challenging task indeed. But about the document, image will be just embedded into it, so it's not a big problem. But again, there should be some read and write servers which allow us to distribute the load. Okay, basic styling, images is easy, different kind of users, readers, writers, and so on.
Yeah, let's talk about
Okay,
users.
so apart from the DNS, we also should have something like an off open ID or OIDC provider, which will definitely allow us to authenticate our users, ideally on the API gateway level. And for every document, we should have a collection of meta.
So how you gonna understand if the user is allowed to perform a particular action on the document?
Okay, user metadata. Just bear with me. While I'm doing that, I'm moving. Apart from the document snapshot storage, I would rather say that we should have a document metadata storage. And for every document,
Okay.
we should know who exactly is an author of this document, and the access level of the document, and next whether it's allowed or not to read this document. So document metadata storage is required. Hello?
Yeah, can you repeat the question, please?
No question, I just asked if you here with me. And did I answer your question if I want to have a
Yeah.
document metadata storage?
Yeah,
Okay.
sure.
So this will definitely allow us to segregate users by their access.
So how it's gonna work? So the out provider is gonna check the permissions, like the permission model mentioned in the metadata, compare with the action and with the user who is doing the action, and then allow it to deny it. Is that
Yes,
correct?
why not? Because I don't see. Obviously, it's a problem on scale. Problem of the scale because we should somehow, maybe not somehow, but we should definitely be able to satisfy the load. But indeed, yes. So we go into metadata storage and check whether the user has access to a particular document or not. ID, yes. Obviously, there
Okay.
should be some cache, I think, because there might be some super popular documents which are edited by too many people. So we should minimize, let's say, number of requests to this storage, because data here is
Okay.
almost, keeping in mind that we have a really
Yeah.
huge amount of writes, much less amount of reads, but still
Hmm.
we have, let's say, much less amount of data reads apart side by side with meta servers and or metadata readers. It would be nice to have a metadata cache.
What cache scheme you're gonna use here? Is it like read through, write through, a combination of several ones?
Let me think what could help us here, because the document is created only once and next we're reading it. Why not? Why can't I go with read through?
Yeah,
Yes, I
good
read through
choice.
because the document access is document access level is changed quite rarely.
Yeah, and when it changes, we can
Invalidate.
just purge the cache
Yeah,
and yeah.
we can just invalidate the cache and it will work. Okay, so what else? Different kind of clients. Oh, so I think we finally covered these requirements about our authentication, different kind of users, comments, and so on. So comments, obviously. Speaking about comments, I don't think it's a good idea to store comment itself as a part of the document, so definitely it should be stored somewhere separately, and there should be, let's say, a marker somewhere in the document saying that there is a piece of comment associated with this piece of document itself. So we can
Okay.
store it, let's say, in a separate table, in separate database, but it's much less complicated than anything else we have here. Moving forward, different kind of clients. I suggested going with progressive web application. Obviously, it is a dirty hack and dirty solution. Ideally, it's better to have a native applications for every major platform, because it would be implement
All right.
CRDT in by using a native application. But still, there are solutions which allow to do it in web. For example, after merge library, which is quite cool.
Okay.
Yeah.
Okay. Good. Let's talk about availability. So, with the
Mhm.
current setup, what availability would you
With the
expect?
current setup, it's really hard for me to estimate it from top of my head, but keeping in mind that we have horizontally scalable read and write servers, we should have some.
Let me ask the question: how many regions you
How
gonna
many
deploy
regions
to?
I need to deploy? At least into two regions. That at least in
Okay.
two regions, keeping in mind that I have some GDPR-like requirements regarding data locality, so it should be deployed in regions. I don't know, at least five, I think. Keeping in mind we're building
Okay.
global solutions, so it's five regions, at least two regions in in at least two availability zones in every region.
In every region. Okay. Good. We didn't talk about the encryption at all. So, are there any components in the system that would grant this
Well,
last?
majority of cloud providers allow us to store data encrypted out of the box. For example, AWS allows us to encrypt data with KMS services. I think in Google Cloud we have the same. And other than that, major database vendors also allow us to store data encrypted. Regarding encryption data in transit, uh, TLS, SSL, key rotation, JWKS, everything is ordinary.
Okay. Any SSL pinning tactics applied?
SSL pinning tactics. Oh, to be honest, I'm not familiar with that. But if you mentioned that, I think we should apply it.
Okay, so that's for the case when you're in an insecure environment. Imagine
Mm-hmm.
public Wi-Fi at McDonald's, and then you're trying to access company
Mm-hmm.
documents, for example. You need to make sure that you're talking to actually a Google server
Mm.
rather than some malicious one. And if you have your certificate storage on the mobile
Mm-hmm.
spoiled, then nothing will save you unless you have the certificate pinned in the application itself so that you can check it yourself. So
Okay,
that's the
good,
case.
good to know.
All right. Anything else you want
No,
to
I
add?
don't think so. And I don't really think that we have more time to talk about CRDT and operational transformation. So,
Unfortunately, not. The only thing that is missing here, I think, is the observability
oh,
stuff. We need to talk about some metrics and alerts. Like, how do we know that the solution is operational?
well, indeed. Well, we have a lot of applications, we have a lot of servers, and I think ordinary Prometheus or even Thanos will not help us doing that. But still, again, we could deploy something like
Hmm.
sorry, I forget the name of the tool. Obviously, we should collect logs. If we're talking about AWS, it has CloudWatch.
CloudWatch.
Yes, indeed, we could use CloudWatch and collect metrics in CloudWatch too, by the way, because it also can store the metrics and have alerting based on
Yeah.
events.
For observability, you have the whole
Indeed.
spectrum of solutions. Like you can go with a classic ELK stack, you can use cloud tools, you can go with observability vendors like Datadog or
Mm-hmm.
Honeycomb or something else. You can configure something yourself, as you mentioned, using Prometheus, Thanos, Grafana, and others like Kibana for logs and so on. Yeah. Okay, I think we designed a pretty well solution. So, folks, if you're building like an analog of Google Storage, this is your reference design. So, yeah, thank you very
Uh,
much, Alex. I think that was interesting for me
yeah,
a lot.
Yeah,
Hope
I
you
enjoyed
enjoyed
that
it as
as
well.
well, and obviously I used some materials for preparing for this session. I definitely recommend you watching some sessions from Martin Kleppen, who told a lot about CRDT if you're interested in
Of course.
collaboration tools and building collaboration tools. Apart from that, please have a look at Apache Wave, which is formal Google Wave, a Google collaborative collaboration platform. So Google built that platform a few years ago, and next they open sourced it. So if you're building something like that, you shouldn't reinvent the wheel and build everything from scratch. Apart from that, obviously there are some libraries which I have already mentioned, like After Merge, which is also interesting. If you have time, please have a look into it. Good.
Okay. Thank you very much. That was a great session. A lot of insights. Hope you folks enjoyed it as well. If you did, don't forget to smash that like button. And of course, share the video with your friends and colleagues. Thank you very much.
See
See
you next
you
time.
next time.